Hello students, let's learn a chapter Similarity. The first article of this chapter is properties of ratio of areas of two triangles. And the first property is the ratio of areas of two triangles is equal to the ratio of products of their bases and corresponding heights. That is, if A1, A2, B1, B2, H1, H2 are areas, bases and corresponding heights of two triangles, then A1 upon A2 equals B1 into H1 upon B2 into H2. Second property, the ratio of areas of two triangles having equal bases is equal to the ratio of their corresponding heights. That is, if B1 equals B2, then A1 upon A2 equals H1 upon H2. Similarly, third property, the ratio of areas of two triangles having equal heights is equal to the ratio of their corresponding bases. That is, if H1 equals H2, then A1 upon A2 equals B1 upon B2. And fourth property, the ratio of areas of two triangles having equal bases and equal heights is 1:1. That is, if B1 equals B2 and H1 equals H2, then A1 upon A2 equals 1/1, or areas of two triangles having equal bases and equal heights are equal. That is, if B1 equals B2 and H1 equals H2, then A1 equals A2. Now let's prove these properties one by one. The ratio of areas of two triangles is equal to the ratio of products of their bases and corresponding heights. That is, if A1, A2, B1, B2, H1, H2 are areas, bases and corresponding heights of two triangles, then A1 upon A2 equals B1 into H1 upon B2 into H2. Let's give a solution for this statement. Let's try to prove this. Let us consider triangle ABC and a triangle PQR. Okay. Now, in triangle ABC, let seg AD perpendicular side BC. Similarly, in a triangle PQR, seg PS perpendicular side QR. Let's mention these things in given. Given in triangle ABC and a triangle PQR, AD perpendicular BC and PS perpendicular QR. We are interested to prove the ratio of areas of two triangles. Means, let's mention here what to prove. Ratio of the areas of two triangles means here area of triangle ABC upon area of triangle PQR, that equals a ratio of the products of their bases and corresponding heights. In the case of triangle ABC, BC is a base and AD is corresponding height. That's why in front of area of triangle ABC at the numerator we are going to write as BC into AD. Similarly, in a case of triangle PQR, QR is a base, PS is a height, and that's why we are going to write there QR into PS. Okay. Now let's prove this. Let's write its proof. Proof. Okay. We have, what have we? We have general formula for area of triangle. And what's that formula? That formula is area of triangle equals half into base into height. Okay. And therefore, area of triangle ABC equals half into base of triangle ABC is BC, height is AD. Half into BC into AD. Let's call it as equation first. Similarly, area of triangle PQR equals half into QR into PS. Let's call it as equation second. And therefore, from 1 and 2, let's obtain a ratio of areas of these two triangles. That is, area of triangle ABC upon area of triangle PQR. area of triangle ABC is half into BC into AD upon area of triangle PQR is half into QR into PS. Now half one's a half, half one's a half will get cancelled, and therefore we are able to write area of triangle ABC upon area of triangle PQR equals BC into AD upon QR into PS. Means a ratio of areas of two triangles is equals a ratio of the products of their bases and corresponding heights. In general, we may write it as that is A1 upon A2 equals B1 into H1 upon B2 into H2. Okay? Now let's prove second property. The ratio of areas of two triangles having equal bases is equal to the ratio of their corresponding heights. That is, if B1 equals B2, then A1 upon A2 equals H1 upon H2. Okay, now we may write directly. We have, what have we? We have A1 upon A2 equals B1 into H1 upon B2 into H2. Okay, this is known as a reason for this, since property of a ratio of areas of two triangles. Okay, and therefore if B1 equals B2, then in this case, as A1 upon A2 equals B1 into H1 upon B2 into S2, we can cancel B1, B2. B1s are B1, B1s are B2. Since B1 equals B2, and therefore we have a result A1 upon A2 equals H1 upon H2. That is, if B1 equals B2, then A1 upon A2 equals H1 upon H2. Similarly, we can prove third property. And what's that third property? Third property is the ratio of areas of two triangles having equal heights. Means a word basis will be replaced by heights is equal to the ratio of their corresponding bases. Okay, as we have replaced heights by bases and bases by heights, we can write here that is if H1 equals H2, that is if H1 equals H2, then A1 upon A2 equals B1 upon B2. Proof: we have A1 upon A2 equals B1 into H1 upon B2 into H2, since property of ratio of areas of two triangles. Now in this case, H1 equals H2 means these are the triangles having equal heights. If H1 equals H2, then as we have a formula, A1 upon A2 equals B1 into H1 upon B2 into H2, and as in this case H1 equals H2, we can cancel. What can we cancel? Yes, we can cancel H1 with H2. H1 ones are H1, H1 ones are H2. Okay, therefore A1 upon A2 equals B1 upon B2, and therefore if H1 equals H2, then A1 upon A2 equals B1 upon B2. Okay, Now let's see fourth property. The ratio of areas of two triangles having equal bases and equal heights is equal to 1:1. That is, if B1 equals B2 and H1 equals H2, then A1:A2 equals 1:1. Or areas of two triangles having equal bases and equal heights are equal. That is, if B1 equals B2 and H1 equals H2, then A1 equals A2. Let's prove this. Proof. Yes, in a proof we may mention we have, what have we? We have a ratio of areas of two triangles is equals a ratio of the products of their bases and corresponding heights. Means A1/A2 equals B1 into H1/B2 into H2. This is called as, since a reason for this, since property of ratio of areas of two triangles. Okay, as here, as B1 equals B2 and H1 equals H2, A1/A2 equals B1 into H1 upon B2 into H2. B1 equal to B2, therefore B1 ones are B1, B1 ones are B2. H1 ones are H1, H1 ones are H2. Since B1 equals B2 and H1 equals H2, and therefore A1/A2 equals 1/1. Okay, and on cross multiplication, A1 into 1 equals 1 into A2, and therefore we have A1 equals A2, and hence if B1 equals B2 and H1 equals H2, then A1 is 2 into equals 1:1, or A1 equals A2. Hence the proof.